We'll have a look at a passing distance problem, and in this problem we're having to work out how many miles north or south we're going to pass. And very standard problems these. You always have to work out the distance, initial and final courses. Of course, the course will enable you to calculate the vertex, and it's the vertex that we use to work out the last part. So part A, very standard. Obviously we're going from a southerly to a northerly latitude, and we're going from a westerly longitude to an easterly one. So our initial course, when we look at that, is going to be named southeast, and that tells us, because it's over 90 degrees, that our vertex must be before position A. So that's our initial course. Of course, we can find it by ABC as well. And then our final course, we've got the formula there. And also, we can set everything out there to get the same value by the ABC tables. So, whichever way you do it, as long as you name them correctly, using the formula or ABC, you should get the same answer either way. So I've done both there to explain what's happened. So let's just have a quick look before we calculate the vertex. The situation we've got here, there's our initial position A, and we're going to position B. So it's very important that you do sketches to help you understand this. We've worked out that our vertex is before position A. So what we're going to have to do is work out the latitude and longitude of the vertex by Napier's, and then we're going to use this value along with the value we're given for the island. Okay, so once we've got those two values, we can then calculate the passing distance for the island. So working out the southern hemisphere vertex, as it says there, as the course from latitude A moves towards the lower latitude, the vertex will be behind latitude A. So the external angle is 73 degrees. Hopefully you can see that from the information that we've got, and therefore the latitude of the vertex is going to be 55.3 south. Longitude, we're going to be going back towards the west, so therefore that's going to increase the longitude, and that's going to be 73 degrees 16.9. So our initial course told us that the vertex was before our initial position. So now on this sketch I've put the value that we calculated for our vertex, and that's the initial position, 1952. So we've gone further south to 2553.3, and of course we've gone further west as well. So the passing distance we need to find, well, the longitude here, 7316.9, and the longitude of the island, which is given in the problem, we can get the difference between them, and it's 6140.9. We know the value of PV, so what we need is PX by Napier's rules. We know PV, we know P, therefore we want PX. And I've done it there, just roughly worked out, it comes to 1257.9 south. But putting it here typed out, we've got the D long, we've got the formula that we use, PV used, and the value that we've calculated gives us our value 7702.1, take from 90, and therefore we've got 1257.9. The island is at 1244, so our passing distance is 13.9 south. So with these passing distance problems, the vertex is the key to solving this last part. Once you've calculated the vertex, you've got the latitude of the vertex, the longitude of the vertex, you'll be given information about the island, and depending on whether you have to calculate north or south like this, or east or west, you'll have the relevant information to solve the problem. but they always follow a similar pattern: initial distance, courses, vertex, passing distance. And the passing distance is, once you've got the previous three values, as you can see, the passing distance is quite a straightforward part of the problem, providing of course you name it the right way. As this, you can see, this one is, I believe, is south of the island.